So in this video, I'm going to be going over question 8.1. So let's start, or question 8. So let's start with this, right? 8.1 says the following. It says complete the following theorem. Now it says that the angle at the center, right? I wonder what theorem this is going to be. Of a circle is twice the angle at what? So I'm pretty sure by now we've heard this theorem so many times. The angle at the center of a circle is twice the angle at the circumference. Okay, so essentially what we are talking about here is if we have a circle like this, and then if I just try and draw a point on the circumference, and then I draw our circle center, and then two random points that will make our chord like this. So we're going to have a chord, right? So one chord, and then our other chords over here, which is going to be this one here. This angle is going to be subtended to this chord that we have created over here. And then so is this angle over here, which is going towards the circle center. Over here. And then we know that this, let's say this would be x, and the angle at the center would be 2 times the angle at the circumference. And it is subtended by a common chord, or we can say the same chord. So therefore it's going to be by the same, the same chord. Okay, so 8.2 says the following. 8.2 says in the diagram below, O over here is the circle center, or the center of the circle. K, L, M, and N are points on the circumference of the circle. So which means because we have 4 points on the circumference of the circle, and they all line up together to make a quadrilateral, we can call that our cyclic quad. Okay. And then now they say that KS is a tangent to the circle at K over here. So they're saying that this KS is a tangent to the circle at K, and L as well over here. And L is going to be equal to 100 degrees. That's the information they're giving us. Okay. So now let's answer the questions here, based on the information that we have. So 8.2.1 says, determine with reasons for A over here, the size of N. So this is a very straightforward one. Like I said over here, this is a cyclic quad because all 4 points are touching the circumference of the circle, and that makes a quadrilateral in the circle. Okay. And what we know about the property of cyclic quadrilaterals is that this, okay, so they give us one angle, which is L, and then we need to consider the opposite angle over here. And what we know about the properties of the cyclic quadrilateral is that opposite angles of a cyclic quad equal 180 degrees. So which means if this is going to be 100 degrees, therefore this N has to be an angle such that you get a total of 180 degrees. So we know that it's going to be 80 degrees. So therefore N is going to be 80 degrees. So if this is going to be 80 degrees, then therefore if you add these two angles together, you'll get 180 degrees. Okay, so 8.2.1 number B over here is actually really straightforward. So what I'm going to do over here is I'm just going to quickly take this one here, and that'll be the answer for number 821A. Okay, so now over here we're going to look at the following information, right? Where's K2? I'm just going to get rid of that there. Oh no, this is 80, sorry. So K2 is here, right? It is this angle here. And what we can see over here is that we have an angle at the circumference, and at least from that information, we will know what the angle is at the center. So let's start with that quickly, right? Okay, if we know the angle at the center, and then we're going to know the following information. But let's first start right by saying that. We're going to say that, therefore, angle MOK, meaning that it's just this angle here, is going to be equal to 2 times the 80 degrees. 2 times the 80 degrees, because remember that the angle at the center is 2 times the angle at the circumference. and 2 multiplied by 80 is just 160 degrees, right? And then the rule that we used over here, or the reason is angle at center is going to be equal to 2 times the angle at circumference. Okay, so that is our angle of MOK. Okay, so now that we have that angle here, right, so I'm going to just write it down. It's going to be 160 degrees. And now what we can see over here is that MO and KO, these two are radii, right? Because at the circle, they are both points that go towards the circle center. And they are actually, and they go from the circle center to the circumference, which makes them a radius. So therefore this side is going to be equal to that side. And then how we're going to write this down is that MO is going to be equal to OK because they are radii. And now from this information, we have an isosceles triangle. And meaning that this angle here, K2, is going to be the same as this angle, M2. So now what we can say over here is that we can actually find one of them, right? So we know, okay, so let's call this, let's say that we're going to let K2, angle K2, because K2 is equal to M2, we're going to let this equal to X. Okay, such that we have angle X here and angle X over here, so that we can solve. Because we have angles in a triangle add up to 180 degrees, we're going to do this, right? We have it being the sum of the angles, so it's going to be X plus our 160 degrees, so it's going to be this angle plus this interior angle plus this interior angle is going to be equal to 180 degrees, and the reason why is because it's the sum of angles in triangle. And now we're going to have 2x, we're going to have x plus x, which is 2x plus 160 degrees. Actually, let's take this 160 degrees over to the other side. We're going to have equal to 180 degrees minus 160 degrees, which is going to give us about an answer of 20 degrees, 2x. And then to get our x value, we are going to divide both sides by 2, such that these cancel, and therefore our x value is going to be equal to 10 degrees. So therefore, because we know that K2 is equal to x, we're going to say angle K2 is equal to 10 degrees. Also, I forgot to add a reason, by the way. The reason why we took the x's, the reason why I said the x's are the same, I forgot to add it here, by the way. For this one, right, the reason why we did that is because we have angles opposite equal sides. And that is the reason why we could let both of them equal to each other, because we have an isosceles triangle. So that is one of the other reasons that we should have had. I just realized it now because I was thinking, I'm pretty sure this reason had to be used in this question because we are using an isosceles triangle. Okay, let's move on to the next question. Okay, so 8.2.2 is a very nice one. I like this one. Prove giving reasons that MN is parallel to KS. So what they want us to say is that this side is parallel to that side. Now what we can do is, if they are parallel, then this angle will be the same as this angle right here, right? Because of alternating angles. So that is what we need to do. It's kind of like a converse of that, right? If you remember your converse proofs, I mean not proofs, your reasons, that's just that you're proving that that is going to be that, right? So the first piece of information is the following, right? We have this K. If we want to find this K, maybe we could find a tan chord, maybe we could use tan chord theorem for the next one, right? And which angle is going to line up with, right? So we know that tan chord theorem, so if we have a tangent there, right, and we have this angle like that, then we need to have an angle that is subtended to that chord that the angle lies on, that is in the circle, right? So we mustn't focus too much on the tangent here, but if we look at the chord that is from on 2 points on the circumference, right? So we can see there's a point here and a point here on the circumference from that angle that we are trying to find, which is K4. Then we need to look at the angle that is subtended to that same chord on the circle, the points on the circumference, and which is going to be this angle over here. Can you see that over there? And that is our tan chord theorem. And we know that the sum, so I'm just going to write it here, we know that M3, so angle M3 plus angle M2 is equal to our angle KMN, which is equal to 70, which is equal to 70 degrees plus 10 degrees, which is therefore going to be 80 degrees. So that's what I'm trying to say. I'm trying to find the angle over here, the KMN, which was the angle in purple. Okay, so now that we know that KMN is equal to 80 degrees, now we can say the following, that therefore angle K4, which is this one in red, is also going to be equal to KMN, which is equal to 80 degrees because of tan chord theorem. And now we have this equal to 80 degrees, right? And because of that, and we know that this angle here is also 80 degrees, we can say that therefore, because angle N is equal to 80 degrees and angle K4 is also equal to 80 degrees, therefore MN, I think it was MN, right? MN is going to be parallel to KS because of our alternative angles, which are equal. And that is how we prove that this MN is actually parallel to KS. So it's not that bad. Once again, you need to know your theorems. If you don't know your theorems, it's going to be a lot more difficult to tackle these questions. So that is question 8.